So welcome students to my channel once again. In this video I have brought this sum for you all. So look at the sum very carefully. The sum is from complex number chapter. Okay, this sum can come in any competitive exam like joint entrance or in any government service exam or in any Olympiad, any kind of tough exam this sum may come. So look at the sum very carefully. The complex numbers z1, z2, z3 satisfying this equation z1 minus z3 whole divided by z2 minus z3 is equal to 1 plus iota root 3, 1 plus iota root 3 whole divided by 2 are the vertices of a triangle which is, four options have been given: equilateral, right angled, isosceles and obtuse angled. That means they have asked that z1, z2, z3 which are the vertices of a triangle, but the triangle is which triangle? Equilateral, right angled, isosceles or obtuse angle. Okay, satisfying this equation, the complex numbers z1, z2, z3 satisfying this equation are the vertices of a triangle which is, four options have been given. So I am starting the solution, you all watch it very carefully. Okay, so equation which has been given, z1 minus z3 by z2 minus z3, right, is equal to 1 plus iota root 3 by 2, right. So name it as equation 1. Okay, now I will take mod on both sides, z1 minus z3, z2 minus z3, right. So this side also mod 1 plus iota root 3 by 2. Clear? So what will happen? This will be mod z1 minus z3 by mod z2 minus z3, right. So here it will be mod 1 plus iota root 3 by mod 2, right. So it would be mod z1 minus z3 by mod z2 minus z3, right. And here it will be mod of 1 plus iota root 3 will be 1 square under root 1 square plus root 3 square. Okay, and mod of 2 is 2 only. Okay, so this will be 1 plus 3 by 2, so this will be under root 4 by 2, so this will be 2 by 2, so this will be finally 1. So mod of z1 minus z3 by mod of z2 minus z3 is equal to 1. So we can write in this way also, mod of z1 minus z3 is equal to mod of z2 minus z3. 1 into this mod of z2 minus z3 will be get multiplied by 1, so it will be z2 minus, so name it as equation 2. Okay, that means the distance between z1 and z3, z1 minus z3 means mod of z1 minus z3, mod of z1 minus z3 means the distance between z1 and z3, the distance between z1 and z3 is same as mod of z2 minus, that means distance between z2 and z3. Mod of z1 minus z3 means distance between z1 and z3 is same as distance between z2 minus z3. Clear? Now again from equation 1, what was the equation 1? z1 minus z3 by z2 minus z3 is equal to, what was there, 1 plus iota root 3 by 2. So now we will subtract 1 from both sides. So z1 minus z3 by z2 minus z3 minus 1. So you have to 1 plus iota root 3 by 2 minus 1. So we are subtracting 1 from both sides. So what will it be? LCM will be z2 minus z3, right? So z1 minus z3 minus z2 minus z3, right, is equal to, LCM will be 2, 1 plus iota root 3 minus 2, right? So it will be in the denominator z2 minus z3, z1 minus z3 minus z2 plus z3. Here it will be 1 minus 2 is minus 1 plus iota root 3 by 2, right? So here look, minus z3 and plus z3 will get cancelled. So z1 minus z2, z1 minus z2 by z2 minus z3, z2 minus z3 is equal to minus 1 plus iota root 3 by 2. Now what will I do? I will take mod on both sides. z1 minus z2, z1 minus z2 by z2 minus z3 mod. So I have to take mod on this side also. Minus 1 plus iota root 3 by 2, right? So this will become mod of z1 minus z2 by mod of z2 minus z3 will be under root minus 1 square plus root 3 square by sorry, this step we will do later. At first, the mod of minus 1 plus I root 3 by 2, it means what? Is equal to, so I am cutting this, it will be mod of minus 1 plus I root 3 by mod of 2, right? Watch up till here. So now see again, mod of z1 minus z2, z1 minus z2 by mod of z2 minus z3, okay, 2. Mod of 2 will be 2, and here the mod of minus 1 plus I root 3 will be minus 1 square plus root 3 square, okay. So this will be 2 under root 1 plus 3, right? So this will be under root 4 by 2, this will be 2 by 2, 2 and 2 will get cancelled, so 1, right? So mod of z1 minus z2 by mod of z2 minus z3 is equal to 1. So from here we can write mod of z1 minus z2 is same as, is equal to 1 into this mod of z2 minus z3 will get multiplied by 1. So it will be mod of z2 minus z3, right? So name it as equation 3. So see equation 2. Equation 2 was this one. This mod of z1 minus z3 is same as mod of z2 minus z3. Okay, and here mod of z1 minus z2 is equal to mod of z2 minus z3. That means distance between, watch it very carefully, distance between z1 and z3 is same as distance between z2 and z3. Okay, and here distance between z1 and z2 is same as z2 and z3. So comparing equation 2 and equation 3, we can say that what was equation, mod of z1 minus z3, mod of z1 minus z3 is equal to mod of z2 minus z3, mod of z2 minus z3, and mod of z2 minus z3 is same as mod of z1 minus z2, right? So distance between z1 and z3 is same as distance between z2 and z3 is the same distance between z1 and z2. So the three points are of equal distance, apart from each other. Distance between z1 to z3 is same as distance between z2 to z3. That means like this, where I have to show, let me find one page. Yes, suppose this is three triangle, this is z1, this is z2, this is z3. Okay, z1, distance between z1 and z3, distance between z1 and z3 is same distance between z2 and z3, z1 and z3 distance is same between z2 and z3 is same distance between z1 and z2, same. That means the three sides are of equal length. That means it is forming these 3 points are forming an equilateral triangle, right? Okay, so since the distance between 3 points are of equal length, see z1 z3 distance, z2 z3 distance, z1 z2 are of equal length, so therefore we can say z1, z2 and z3 are the vertices of an equilateral triangle, right? That means yes, this one. So in the question we have been asked that the complex numbers z1, z2, z3 satisfying this equation are the vertices of a triangle which is, so what should we say, equilateral. Definitely are the vertices of an equilateral triangle. The length of these three, the distance between the 3 points are of equal length. So option number A will be right answer. Clear? Thank you.